Welcome to Lesson 10 of Module 3, Quadratic and Exponential Word Problems. Exponential functions often describe exponential growth and exponential decay. So when working with these word problems, you'll have to pay attention to keywords to determine whether you're going to use the growth formula or the decay formula. So the formula for exponential growth is y equals a times the sum of 1 plus r to the power of t. Y is your final amount, a is your initial amount, r is the rate of growth in decimal form. So these word problems are going to give you a rate of growth as a percentage, and you'll have to convert the percentage into a decimal in order to substitute it into the formula. And t represents time. The exponential decay formula is very similar. It's y equals a times the difference of 1 minus r to the power of t. The variables all mean the same thing. The only difference here is that we're using subtraction instead of addition. So let's take a look at an exponential word problem. Now that we're working with word problems again, I encourage you to use the 3 reads protocol that we were using in the previous module. It's been a while since we've done some word problems, but please use the 3 reads protocol so that way you get into the habit of reading the problem 3 times and just kind of figuring out what the story is about, identifying your quantities and relationships. Remember, that's the most important part. The second read is the most important read. And then using those quantities and relationships to solve the actual problem. Some banks charge a fee on savings accounts that are left inactive for an extended period of time. The equation y equals 3,500 times 0.85 to the power of x represents the value y of one account that was left inactive for a period of x years. What is the y-intercept of this equation and what does it represent? So this question is asking us to identify the y-intercept and interpret it. So which piece of the equation would represent the y-intercept here? Remember, a was the initial amount. And in word problems, the initial amount is always the y-intercept, or the y-intercept is always the initial amount. It's that starting value. So our value of a is 3,500. So I can already cancel out choice B and C, right? Because choice B and C says that 0.85 is the y-intercept, and we know that that's not true. So let's take a look at A. 3,500, the amount of money in the account after X years. And D says 3,500, the amount of money in the account initially. So choice A, the amount of money in the account after X years, that would be your final amount, right? That would be your value of Y. So it's not A. It's choice D, 3,500, the amount of money in the account initially. Your y-intercept is your initial amount, your starting value, right? So 3,500, that was our value of A, and we know that the y-intercept is the initial amount. And A in the formula represents the initial amount. Now, I just want to take this opportunity because we have this equation here to look at this number in the parentheses, 0.85. There will be some questions that you encounter where, based on the equation alone, you might need to use the equation to identify whether it's exponential growth or exponential decay. So when this number in parentheses is greater than 1, then you know it's exponential growth. If it's between 0 and 1, then you know it's exponential decay. And that makes a whole lot of sense because in the growth formula, that number in the parentheses is 1 plus r. you're adding whatever the rate of growth is to 1. So that number has to be greater than 1. And in the decay formula, you're subtracting the rate of decay from 1. So that number has to be less than 1, but specifically it'll be between 0 and 1 because it won't be negative. Now moving on to quadratic word problems. Quadratic equations are often used to model situations that involve projectile motion, maximum and minimum values, and relationships between time and distance. So the general form of a quadratic, we've seen this before, the standard form is y equals ax squared plus bx plus c. Some key features that will be important, especially in these word problems, are the vertex. That's going to be your maximum or minimum point. If the question's asking you something about the maximum or something about the minimum, then you know that you need to find the vertex. The roots, or remember the solutions, the x-intercepts, the zeros, that's where y equals 0, and it often represents times or distances. You might encounter problems where they ask you, after how much time did a certain object hit the ground? Then you would be looking for this 0 right here, the second 0, the second root, right? Because where's the ground? The ground's on the floor, the ground is at 0, right? 0, your x-axis is ground level. So if an object is moving up and then down, that second 0 is where and when it hits the ground. And your axis of symmetry is another key feature of the graph of a quadratic. So let's take a look at a quadratic word problem. A ball is thrown upward, and its height h in meters after t seconds is given by h of t equals negative 5t squared plus 20t plus 1. What is the maximum height of the ball, and when does it reach its height? So this question is asking for two things. It's asking, what is the maximum, and when does it reach its maximum height? So for these word problems, yes, there are algebraic ways that you can solve them, but the best way to answer these problems is by graphing it and looking at the graph. Especially, I told you, you have that Desmos calculator on Blue Book for the digital SAT. Use and abuse it, right? And when you graph this equation, you're going to get something that looks like this. And I've identified the vertex here, right here, at the point 221. So now we have to interpret the vertex. What does the 2 represent? What does the 21 represent? The 2 is your x value, which in this case, your t value. So that represents time. Okay, so the 2 here represents 2 seconds. And what does 21 represent? The y value, right, or your h of t value, represents the height in meters. So that means that the ball reaches its maximum height of 21 meters in 2 seconds, right? So we identified the vertex. If you're dealing with a maximum or minimum problem, you're looking for the vertex. And the ball reaches its maximum height of 21 meters in 2 seconds. Please pause this video and work on the Lesson 10 Level 1 problems in the workbook. Moving on to some intermediate questions. RB projected a ball up into the air from the surface of a platform to the ground below. The height of the ball above the ground in feet is modeled by the function f of t equals negative 16t squared plus 96t plus 112, where t is the time in seconds after the ball is projected. State the height of the platform in feet. Okay, so we know that RB is projecting the ball from the surface of a platform. So that means he's starting from the platform. The starting point is the platform. The starting height, the initial height is the platform. So remember, when we did our lesson on quadratics, the C value represented the initial value, represented the y-intercept. So that means the height of the platform is 112 feet, right? That's because since the ball is being projected from the platform is the initial height, and that is your C value. How long will it take for the ball to hit the ground? Well, like I said in level 1, you want to graph the equation for something like this. And I asked you, well, where is the ground, right? Your x-axis is the ground because the ground level is at 0. So that means right here, this is where and when the ball hits the ground. So it's asking how long will it take for the ball to hit the ground? So what's the x value here? What is your 0? It's 7. So it will take 7 seconds for the ball to hit the ground. Let's take a look at an intermediate exponential word problem. Pavel has his money invested in a stock portfolio. The value v of x of his portfolio can be modeled with the function v of x equals 50,000 times 0.87 to the x power, where x is the number of years since he made his investment. Which statement describes the rate of change of the value of his portfolio? So let's go through them and see which one makes sense. Choice A says it increases 13% per year. Well, I know that that's not the case because remember I told you to look at this number in the parentheses. It's between 0 and 1, which means that this is exponential decay, so it's going to decrease, right? Just to remind you, here's your exponential decay formula here, and because this number in the parentheses is 1 minus r, that number has to be between 0 and 1, and 0.87 is between 0 and 1. So that means we are decreasing, we are decaying. So right away, I'm going to cancel out choice A and choice D. So now it's between choice B and C. Does it decrease 87% per year, or does it decrease 13% per year? Well, you might be tempted to choose choice B and say that it decreases by 87% per year, but you would actually be incorrect in doing that. And here's why. 0.87 is the result of 1 minus r, right? Once we subtract r from 1, that's how you get 0.87. So if 1 minus r is 0.87, what's the value of r? Well, we can subtract 1 on both sides and solve for r. We get negative r equals negative 0.13. Divide by negative 1, and you get r equals 0.13, which is 13%. So it decreases 13% per year. Or you could have just asked yourself, 1 minus what is 0.87, and you would get 0.13. So be very, very careful when it comes to these exponential decay problems. This choice here, choice B, there's always a similar choice to that because they know students are going to go for that choice B. It decreases 87% per year. But if you do that, you'll be incorrect. Please pause this video and work on the Lesson 10 Level 2 problems in the workbook. Moving on to Level 3 problems. A car was purchased for $25,000. Research shows that the car has an average yearly depreciation rate of 18.5%. Create a function that will determine the value v of t of the car t years after purchase. Determine to the nearest cent how much the car will depreciate from year 3 to year 4. So there's a lot going on here. We need to create a function, and then we need to do some interpretation. But the first thing that you want to do is write the function, but we need to determine, are we using exponential growth or exponential decay? Well, this word here, depreciation, that means decay. So substituting into the exponential decay formula, we'll get v of t equals 25,000 times 1 minus 0.185 to the power of t. So that answers the first part here. Create a function v of t. Now we have to move on to the next part. So we'll have to evaluate v of 3 and v of 4 separately. So substituting 3 in for t, we get v of 3 equals 25,000 times the difference of 1 and 0.185 to the power of 3. Just put that right into your calculator. And to the nearest cent, right, you should do the rounding now, not at the end. To the nearest cent, you'll get 13,533.58. Now we'll evaluate v of 4. Just substitute 4 in for t, put this right into the calculator, and rounding to the nearest cent, you get 11,029.87. So now we have to do something with the values of v of 3 and v of 4. We'll have to subtract v of 4 from v of 3 because the question is asking us how much the car will depreciate from year 3 to year 4. So what was the difference between those years? So remember, v of 3 is 135,033.58 and v of 4 is 11,029.87. When we subtract those two numbers, we get 2,503.71. So the car will depreciate $2,503.71 from year 3 to year 4. Please pause this video and work on the Lesson 10 Level 3 problems in the workbook. Once you're finished with the problems in the workbook, you can stop this video and move on to the next one for Lesson 11.